Hello guys, welcome to my new channel Medicinal Pharma Education. In yesterday's class, we have discussed about the flame emission spectroscopy. In that we have discussed about the principle and instrumentation. In today's class, we are going to discuss about the interference and applications of flame emission spectroscopy. In next class, we are going to complete the atomic absorption spectroscopy. We'll study the same principle, instrumentation, interference and applications. Hope you are liking the video. If you are new to this channel, welcome to my new channel, and let's continue with the topic, interference of flame emission spectroscopy. Okay, in the interference of flame emission spectroscopy and atomic absorption spectroscopy are quite bit different, but the concept is similar. Okay, so that I have scratched it. They have separate interference. Okay, let's start with the interference. Okay, interference is a phenomenon that leads to change in the intensity of the analyte signal in the spectroscopy. See what is meant by interference. Interference is like, I'll just give a simple example for better understanding of you. If a class teacher is teaching a lesson, and you are getting all the knowledge of the teacher, but some interference like backbenchers are making noise, that interferes between the teacher and you, the student. Here in the instrumentation, the interference between the sample and the detector, what are the factors affecting the signal between these both is called interference. In the class, the interference is the backbenchers. In here in the instrumentation, the interference is mainly three types. Okay, spectral, ionization and chemical. These are the factors which affect the intensity of the sample. Okay, see, number of factors behind the analyte factor, the intensity of emitted radiation are affected. Okay, there are number of factors behind analyte affect the intensity of emitted radiation, which affects the emitted radiation. Okay, there are mainly three types: spectral, ionization and chemical. Okay, I think so you have understood the meaning of interference. First we'll go through the spectral. What is meant by spectral interference? Okay, the spectral interference affects the spectral intensity or resolution. What is meant by intensity? Intensity is how much the light uh, capacity, how much the capacity of light is emitted by the sample. That is the intensity or resolution. Okay, the spectral shift affects the intensity or resolution. It may be by three ways. First way, interference that rises when two elements exhibit spectra which particularly overlaps both emitted radiation at a wavelength. It's a simple interference. I'll just give you the diagram of it. See, in the first type, see, I'll just read once again. Interference rises when two elements exhibit spectra which particularly overlap both emitted radiation at particular wavelength. See, example, fluorine and copper. See what happens here. The iron and copper spectra is almost like same. See, this copper also gives the same spectra, so that this overlap occurs, right? Overlap between two each other. This is very difficult to find which is iron or which is copper. This is a type of spectral interference. This is a common type of spectral interference. You see example, Fe lines at 324.73 nanometer overlaps with copper line at 324.75. Okay, thus can be overcome by taking alternative wavelengths with no overlap. See, this is the main interference. It can be overcome or it can be prevented by taking alternative wavelengths. Okay, next reason is because the next reason is because interference that rises when the spectral lines of two or more elements is close but their spectra does not overlap. Here what is happening, right? If it's like you are listening to two people simultaneously, their speech is different but you can't understand the both speech. I'll show you in this way. See, here this is the first one. In the second one, you are getting a graph. You're getting the spectra, getting the spectra, getting this spectra, and you're getting this spectra. The spectra are different. The spectra are different, but you can't identify which, you can't know which spectra is which element. Okay, okay, this is what happened. This is the second spectral interference. See, I'll just read it out, you will better understand it. Interference that rises when spectral lines of two or more elements is close, but their spectra does not overlap. The filters may allow spectral line separation by 5 to 10 nanometer to pass through. This results in error in analysis. As the filter allows 5 to 10 nanometer, right, the range in the 5 to 10 nanometer may affect the final result. This is the second reason. Next, the third reason is because, see, the third reason of spectral interference is interference occurs due to presence of continuous background which rises due to higher concentration of salts in the sample. If you take higher concentration of the salts, this interference occurs. Okay, I think so. Understood the spectral. Next, we are going with the ionization. Ionization is very simple. See, I'll just tell you the topic. See, here sodium is ionized into Na plus and electron minus. See, here the sodium and Na plus has both as the wavelength, and these both wavelengths are different. This is the interference in the ionization spectrum. See, the certain cases higher temperature flame may cause ionization of the metal ions. Okay, in case of sodium, it causes sodium is converted into sodium plus and electron minus. Okay, see, here the sodium ion possesses an emission spectrum of its own frequency which are different from those of sodium. See, it gives also one frequency and this gives also frequency. These two frequencies may affect the result. This is called as ionization interference. Okay, next, the chemical, this is like very important. Chemical interference, this rises when the reaction between the different interferent and the analyte. Here it is a reaction. You know, right, chemical interference means the chemical means there is a reaction. Okay, reaction between, there are mainly three types of reactions. See, uh, cathode anode interference, cathode interference, and oxide interference. Okay, I think so I've understood. You have seen the three types. First, we will go with the cation anion interference. Presence of certain anions such as oxalates, sulfates, and aluminate in the solution may affect the intensity of radiation emitted by the element. If the ions such as oxalate, sulfate, and aluminate in the solution are present, they react with the cathode and causes the interference. Okay, next, cathode interference. Here, mutual interference of cathode results in reducing elemental signal intensity. Here, the cathode interferes with each other and they will decrease the intensity of the sample. Next, oxalate formation. Due to formation of stable metal oxide, if oxygen is present in the flame, results in reduced signal intensity. See, here oxygen forms an stable compound with the sample, then there is no emission, because if there is an unstable compound, when the molecule moves from the ground state to the excited state where it is unstable, so it emits the light is measured. But if it forms a stable compound with oxygen, the light is not emitted. This affects the result. These are the three types of interference involved in the flame emission spectroscopy. We will discuss the application and we will wind up this video. Okay, see, applications are very easy. You can write there are many applications, but I have mentioned quite important one. Okay, determination of small amount of metals such as lead, mercury, calcium and manganese. Okay, next, it is used in quantitative and qualitative, both qualitative and quantitative analysis of different drug compounds to estimate lead in petroleum products, determine the alkali and alkaline earth metals. In food industry, we also use determine our calcium and iron in beer. There are many applications. You can just refer the Google for that. I think so. These applications are more than enough. Okay, for your exam point of view. Then in the next video, we will continue with the atomic absorption spectroscopy. We will just write down the notes. If you find this information useful, please like and please comment. It will make my day. Thank you guys for supporting me so much. Please comment and tell your opinion. It's very important for me because making the notes, which is very hard, and understanding the concepts for me is quite difficult, and explaining you it's also a difficult thing. So guys, please encourage me by subscribing and liking this video, and if possible share it. These are three forms, these are the three types of chemical interference. Next, the applications. Next, in tomorrow's class, sorry, next class, we are going to discuss the flame atomic absorption spectroscopy. By this, we'll complete the spectroscopy. Thank you guys. Have a nice day. Have a great day. Bye. See you in the next class.